Hey, so we've got this problem and it says determine whether or not the relation represents a function. Assume A, B, C, and D represent different values. All right. So um a relation is a function if for every element of the domain, there's one and only one element of the range. So a relation is a function if for each element of the domain there is one and only one element in the range. And only one I'm going to underline. All right. So the way I like to do these is to look at each of these elements. So we have our x values and our f of x values. So we have b to d, that's this first one. A to d, that's the second one. And d to a, that's this third one. So we have to ask ourselves, are there any repeated x values? There's not. We have b, a, d. That's fine. Each of them map to an element, which is good. So this is a function. This is a function. Because for each element of our domain, x, it maps just to one value. We don't have that b maps to d and c. It maps just to d, so we're good. A can also map to d, and d can map to a, and that's fine. But we can't have two elements of our x map to two different elements. So, like an example of something that's not a function. So, I'm going to kind of do a little squiggle line and say a non example is if we had x, f of x, and if we had, let's say, a, b, a, c, and let's say A went to B, B goes to C, A goes to C, and C goes to D. This is not a function because we have one element of the domain A that's going to two different elements of the range. Our one element of the domain A is being mapped to two elements B and C. And our definition up here says for each element of the domain, our A, there's one and only one element of the range. Here we had two elements, B and C. Here, each of our elements, B, A, and D, mapped to only one element. It's okay if we have repeats on this side, the f of x side, but we can't have repeats on this x side and that don't match up.